Hello and welcome back. This is section 8, and this is a section over volumes of cylinders, cones, and spheres. We don't want to confuse the concept of spheres with that movie starring Dustin Hoffman, Sharon Stone, and Samuel L. Jackson. Okay, so these are balls. Okay, just like a basketball or something like that. Okay, what we want to do is we want to write expressions to represent volumes or unknown measures of cylinders and cones. Okay, we want to solve mathematical and real-world problems involving the volume of a right and oblique cylinders. Same thing with right and oblique cones, and solve mathematical and real-world problems involving volume of spheres. So the first things first, let's talk about the volume of a cylinder. Is the same concept. Okay, we have the volume is equal to the area of the base times the height. Now, in a cylinder, the base shape is a circle. Okay? So if we were to talk about the area of a circle, we know that that's pi r squared. So that's where we get this idea, where the volume of a cylinder is pi r squared times h. Where h is your height. Okay, so let's talk about this. So we've got r is equal to the radius of the base, okay, and h is equal to the height of the cylinder. Okay, so both of those values we can easily find. It's really not; these aren't too bad. Okay, so let's go ahead and let's kind of talk about and let's kind of color code these real quick. Here's my r, my radius of the base. That's this length down here. Okay, so you see that we have the circle base. Okay, your radius is that piece right there. The height of your cylinder is this distance here. Okay, and it really just connects the center of this top circle to the center of this bottom circle. Okay, you could also measure that height if it's a right cylinder as this measure here too. That would also be your height. It's going to make a right angle. Okay, so all right. So let's apply this formula for the volume of a cylinder. So we have chicken noodle soup. Comes in a can that is 4 inches tall, okay, here. And that's my height, okay, and has a diameter of 4 inches. Okay, now remember, the diameter is all the way across. Okay, it's the distance all the way across. So the radius of this can would be this distance right here. And that radius would equal 2 inches. Okay, so we have that. All right, so we've got our height is 4 and our radius is 2. Okay, so now we also know that the tomato soup comes in a can that is 3 inches tall. So that height, and I can't get a good zoom in on this for some reason. Okay, so we've got a height that's 3 inches tall. Okay, and then we have a diameter that's 4.5 inches. Okay, so if I take 4.5 inches and divide it by 2, that's going to give me a radius, which is this length here. All right, and this radius is going to equal 2.25 inches. Okay, now if the soup cans cost the same, which one's a better deal? Okay, so which one has more volume? So that's the question. So if they cost the same, which one do you get more soup out of? Okay, so when this says which one's a better deal, which can has more volume? Okay, so let's first work with the chicken noodle. Okay, and personally, and I don't know about y'all, but homeboy here likes chicken noodle quite a bit. So let's do the volume of chicken noodle. Every time I hear the word chicken, or I think of that movie Tommy Boy, where he gets on the plane and he's acting like the flight attendant. He's like, "What are we having tonight? Chicken or chicken?" All right, so the volume, we've got pi r squared times h. Okay, so my radius was 2. Our height was 4. Okay, so let's plug those in. So our volume then is going to equal pi times 2 squared and then times 4. Okay, so our volume, 2 squared is 4, so we got volume is pi times 4 times 4. 4 times 4 is 16, so I'm going to do 16 times pi. Okay, now this value here is your exact volume, okay? And so, but let's just go ahead and do 16 times pi. 16 times pi. And that's going to give us a volume of approximately 50.27. So 50.27 inches cubed. Okay, that's the volume of chicken noodle soup. All right, now let's do the tomato. Now, tomato's okay. But you know what? Like, when was the last time you guys had legitimate, like, homemade tomato soup? You know, I don't know. I don't think I've ever had it. I think it's always strictly been out of the can. Whereas chicken noodle soup, usually, you know, my mother, you know, whenever she gets like a chicken or after like Thanksgiving or something like that, she'll make turkey noodle soup, and it's always pretty good. You know, I like when she makes it homemade. So I don't know. You know, I encourage you guys to get out there, get in the kitchen, and try some of these recipes out. It could be fun. All right, so same volume formula, pi r squared times height. Our radius was 2.25. Our height was equal to 3 inches. So our radius is a little bit longer, but our height isn't as much. Let me double check that those are the values. Okay, so methinks if I were a betting man, which I'm not, I would think that this one's going to be bigger. Okay, but let's just double check and see. So let's do this. Let's find our volume, and we're going to do pi times our radius, so 2.25 squared, and then times our height. Okay, if I do 2.25 squared, that's going to give me quite a big decimal here. Pi times the quantity. Let me just double check that. 2.25 times 2.25 is 5.0625. Okay, I'm going to multiply that by 3, which is my height, and I should have put a 3 in there. So I'm going to take that number and multiply it by 3, and that's going to give me volume is pi times 15.1875. Now, if I take that number and multiply that by pi, that's going to give me an actual volume of 47.71. So 47.71 inches cubed. Okay, and that's our volume. So which one has more volume? And it's the chicken noodle soup. Okay, so this one, and I'm going to write this over here, this has more volume. Okay, so it's a better deal. More volume, so it's a better deal. Okay, so if I were in the store and I saw something like that, you know, and usually you can check on, you know, how many ounces are in it, and that will kind of tell you the same thing too. But be a smart consumer out there. Don't get duped into buying something stupid. Happens to me all the time. Wish it didn't. Okay. All right, so now let's talk about the volume of oblique cylinders. Now, it's going to be the same thing. Okay, same formula. And I'm going to write that down over here, that this is going to be the same formula. Okay, so an oblique cylinder is a cylinder in which the segment that connects the centers of the bases is not perpendicular to the bases. So your height is over here. Okay, it's 8.2. So now what they want us to do, you know, we have the same formula. We're still going to use the formula volume equals pi times the radius squared times the height. Okay, now we know that the height is equal to 8.62. Okay, and it gives us that information too. Okay, and it says that the volume is 346.9 centimeters cubed. And we want to find the radius. Okay, so we're going to use this formula. I'm going to plug these values in and see what we get. So for the volume, I'm going to put 346.9 is equal to pi times the radius squared times the height, which is 8.2. Okay? Now, I'm going to reorder this. I'm going to zoom in and write a little bit smaller. I'm going to reorder this and say 346.9 is equal to 8.2, okay, this value times pi, times the radius squared. Now, I'm multiplying by 8.2 and pi. Both of these are numbers, so I'm going to divide both sides by 8.2 times pi. So I'm going to divide by 8.2 times pi, okay? So these are going to divide out, and so then my radius squared is equal to 346.9 divided by 8.2 times pi. Okay. Now, what I would do is I would take the square root of both sides here, and I find out that my radius is equal to the square root of 346.9 divided by 8.2 times pi. Okay, so I'm going to do this. In your calculator, you could do 346.9 divided by 8.2, okay? And then you could just continue to divide that by pi, okay? And that's going to give you roughly 13.46. So what ends up in here is going to be, this value right here, okay, is going to be the square root of 13.466, okay, approximately. Now, I'm just using the calculator, so I'm just going to square root that, and that's going to give me that my radius has an approximate value of 3.669, okay, and that's the idea, all right? So, kind of depends on how you round it. What did they want? Rounded the nearest tenth. It's rounded one decimal place. So this is actually going to give me that my radius is equal to 3.7, and this is inches? Centimeters, okay? And that's that, okay? Let's go to the next page. All right, so let's move on to cones, all right? And the volume of the cone is similar to the volume of a pyramid. So cones and pyramids are similar in that you take the same formula as you would for a cylinder or a prism, and you multiply it by a third or divide it by 3, okay? And so, and here's your base. Your base is a circle, okay? Your height is perpendicular from the apex down to the center of that cone, and then your radius is the distance from the center of that base to the outside, okay? And we also know that, if I were to take 2 of these radiuses, it would give me 2 of them. All right, so that's where they get these 2 R's and the 2 X's. Okay, so let's use this formula for the volume of a cone. Okay, so if we were to do this where it says calculating density, or as I like to call calculating destiny, the company packages treats that consists of a cone filled to the top with frozen yogurt and fresh berries. Okay, and you know what? Everybody likes treats. The company routinely performs quality control tests to ensure that the density, not destiny, of berries to yogurt is at least 1 berry per cubic inch. The cone shown here contains 19 berries. Okay, does it pass the quality control measure? Okay, so the question is that for every berry, 1 berry represents 1 cubic inch. Okay, so we want to see, does this pass the quality control measure? Is that, do we have a volume? Does volume equal 19 inches cubed? Okay, so that's the question that we're asking ourselves. All right, so now here's what I know. I know that my height, this measurement here, the height is equal to 6 inches, okay? Now my radius is a little bit harder to find. Now what I know is that my diameter is 3.8. And I know that because this line is stretched all the way across that circle, okay? If it's not stretched all the way across that circle and you only see part of it, then you can assume that's the radius. But we're going to do 3.8, we're going to divide it by 2, and that's going to give us a radius of 1.9 inches, okay? So let's go ahead and plug this into the volume formula, okay? So if my I'm going to type in my volume formula. Volume is equal to 1/3 times pi r squared times h. My radius was 1.9 inches. My height was 6 inches. And let's plug that in and see what we get. All right, so I've got this where I've got 1/3 times pi times my radius, which is 1.9 inches squared, and then times 6. Okay, so if I take 1.9 and multiply it by 1.9, it's going to give me 3.61. So my volume is equal to 1/3 times pi times 3.61 and then times 6. So then if I take 6 and divide it by 3, those will divide out to 2. All right? So now let's check it out. See what we get. I got pi times 3.61 and then times 2. So this is what I'm going to plug into the calculator. I'm going to do 2 times 3.61. Okay? And that's going to give me 7.22. So now my volume is equal to pi times 7.22. Okay, and then I'm going to multiply that by pi, and that's going to give me a volume of 22.68. Okay, now this is centimeter, inches, yeah, inches, okay? This is just inches cubed. So my volume is equal to 22.68 inches cubed, okay, but I have 19 berries. So does this meet the quality control standard? Do I have one berry for every cubic inch? And the answer is no. No. Okay, does not meet quality control standards. Quality control standards. Okay, and that's what we're looking for. So we can apply this concept of a formula to evaluate these and get the value that we want. Okay, so now the next one, we want to determine the height of the cone. Now in this cone, what I know is that my radius here is 2, but the slant height here is 7. And we're trying to find this height here of that pyramid. So what I want to do is I know that what this makes is a right triangle, and I have a friend. And his name is Pythagoras. Okay, so I'm going to do h squared plus 2 squared. That's going to equal 7 squared. So h squared plus 4 is equal to 49. I'm going to subtract 4 from both sides. So we get that our height squared is equal to 45. So if I take the square root of that, okay, so if I take 45 and the square root, okay, we're going to round this to the nearest tenth. Okay, my height, my exact value would be the square root of 45. Okay, but my height is approximately 6.7 inches. Or what is it, centimeters? What are we doing here? Whatever, units. 6.7 units. Okay, and that's the height. Okay, so we do have right triangles, and that's what we'll be using. Okay, the volume of cones. Okay, so an oblique cone is a cone in which the segment that connects the apex of the center of the base is not perpendicular to the base. So your height is this distance here, okay, is this distance 9, okay? Now the formulas, again, for oblique cones, the formulas stay the same. So the formulas stay the same, okay? And so I still know my radius. Okay, here is 5. Okay, so r equals 5. So over here, I'm going to write r equals 5. And I know that my height is equal to 9. So let's calculate our volume. Volume is equal to pi r squared, 1/3 pi r squared. So 1/3 pi r squared h. So our volume, then, is going to be 1/3 times pi times our radius, which is 5 squared, and then times 9. Now the 9 and the 3 divide out, okay? 9 divided by 3 is going to give me 3 over 1. So then my volume is going to be pi times 5 squared times 3. Okay, well 5 squared is going to give me 25, so volume is equal to pi times 25 times 3. 25 times 3 is going to give me 75, so we get 75 pi All right? So if I take 75 and multiply it by pi, that's going to give me a total volume of 235 point, oh crap, they just want us to leave it in terms of pi, 75 pi. And this is units cubed. Okay, if you were to evaluate it, you get 235.619 units cubed, but this is exact. Okay. All right, let's go to the next page, talk about some spheres. Okay, so for whatever reason on this page, that thing got cut off, and this should say spheres here. And this is not to be confused with that movie that stars Dustin Hoffman, Sharon Stone, and Samuel L. Jackson. You know, and I want you guys to notice the sphere that is inside of the movie. So the movie is about this sphere. It's really an interesting movie. I kind of want to go back and watch it. I haven't seen it in years, but you know, I recommend it. It's PG-13, so it is suitable for y'all. All right, so let's talk about this for a second. And what we want to know, we have the volume of the sphere is 4/3 pi times your radius cubed. Okay? So your radius is this value right here. So let's apply this formula for the volume of the sphere. So what we have, it says people often describe the size of hail by comparing it to the size of everyday objects. Okay, and hail is the size of a golf ball is 1.75 inches in diameter. Okay, while the baseball size hail is 2.75 inches in diameter. So we want to know how much greater is the volume of baseball size hail than the golf ball size. Okay, round to the nearest hundredth of an inch. So what I'm going to do is I'm going to draw a picture here. Okay, and how I draw a sphere is I draw a circle as best I can. Okay, and then I draw this line that goes across like that, and then I draw a dotted line, a dotted circle on the other side. Okay, and I put my value in here, and this is my radius. Okay, so we'll call this the baseball size. Okay, and then we'll do the golf ball. Okay, I'm going to make this a little bit smaller. Make it like that, and like that. Draw my center and my radius. Okay, so now if my diameter of a baseball is 2.75, so diameter is equal to 2.75. For my golf ball, the radius was equal to 1.75. Okay, I'm going to define, or I'm sorry, my diameter was 1.75. To find the radius, let's divide each of those by 2. So 2.75 divided by 2 gives me a radius of 1.375. Okay, so that's my radius for the baseball. All right, and that's this value here. For my golf ball, if I take 1.75 and divide that by 2, that's going to give me a radius of 0.875. Okay, and that's this value right here. So the volume of the baseball, okay, is going to be 4/3 times pi times your radius cubed, so 1.375 cubed. Okay, so let's evaluate that in the calculator. So I've got 1.375, raise that to the third power, okay, and that's going to give us about 2.59. Okay, I'm going to multiply that by pi, okay, and then multiply that by 4, okay, and then divide that by 3. So we get a volume of 10.89 inches cubed, okay, for my baseball. All right, now for the golf ball, let's plug in that value. So I've got volume is equal to 4/3 times pi times the radius, which is 0.875 cubed. Okay, so 0.875, raise that to the third power, is going to be 0.669. Okay, I'm going to multiply that by pi, multiply that by 4, and then divide by 3. And so we get a value of volume of 2.80 or 2.81 inches cubed. Okay, so it's a little bit smaller, quite a bit smaller actually. And so the difference in the volumes, okay, so the difference in the volumes is, and let's do this, volume equals 10.89 minus 2.81. So we've got 10.89 minus 2.81, and that's going to give us a difference of 8.08 inches cubed. Okay, and that's the difference in volume. So, guys, a lot of this is just recognizing formulas and applying those concepts. So, hope you enjoyed these notes. I hope you enjoyed this section. It's one of my favorite sections, and we'll see you soon. Thanks a lot. Talk to you later. Bye.